This video is going to cover the concept of loop controls or loop statements inside the C# language. To demonstrate these, I'm going to create a new project. I'm going to choose under the Visual Studio templates a Windows Form application, and I'll call this CP Week 4. These videos will be functioning as a series, so if at any point you're watching any other videos from week 4 and you may get confused or unsure of how did he get that project set up, you'll want to come back to this video to see how to set up the project. Now that we have a project, we have a single form. I'm going to want to go through and set up a working space for this form. So I'm going to choose my toolbox, and I'm going to grab a text box, and I'm going to click on the accelerator and convert this to a multi-line. This multi-line box I want to have span most of the page, and then on page load I want to add a loop. So I'm going to double click on the form. Double clicking on the form will create an event handler for the default event, which is form load. So inside of my form load method, I'm going to write a series of different loops. The loops we're going to cover are for loops, for each loops, while loops, and do while. Now many of these loops should be pretty familiar to you if you've taken C# or any other programming language. The loop syntax is very C-based, and it's very common. So for loops are loops that go from a starting point value or a starting number to a completing number and then iterate at a given step or interval. So the syntax for a for loop is for, and then inside of parentheses you will say you will define a variable and set the starting value. So in this case we'll say int I equals 0, so we'll start at 0, semicolon, and then this is a logic statement, and it'll basically consist of while I is less than 10, and then for every step of the loop we'll want to do I++. I++ meaning take I and add 1 to it. So this loop will loop from 0 to 9, so while I is less than 10, so start at 0 and then it'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then terminate after 9. Then inside of this loop, what I want to do is I want to write to the text box on my form, which is called textbox1. I'll say textbox1.text, and then I'm going to do a plus equals, which basically means to take the current value inside of the text box and add a new value to it. And I want to take I, which is an integer, and do a toString. And then I want to do an environment dot new line. And what this is it's a constant that's defined by the framework that explains to our program how to define a new line or a carriage return. So we'll go ahead and use that environment new line so we don't have to put in our new line string, and it'll always work. So what this should do for us is it will do 0, 1, 2, 3, 4, 5 all the way up to 9 inside of our text box, looping down the line. Now I'm also going to add textbox1.text equals for loop results. So that'll be kind of our header for the text box. So if I F5 to compile and run, the app will run, and it'll output for us for loop results. There's our 0. I need to add a new line there to break. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Perfect. Going to append to this first is the environment new line, and then I'm going to adjust this for loop so that it goes from 1 to 10. So I'm going to start at 1, and I'm going to say while I is less than or equal to 10, perform this logic. So again, loop from 1 to 10 now. So I starts at 1, and while I is less than or equal to 10, it'll execute this statement inside of the for loop, which is to push I into the text box and a new line character after it. F5 to recompile and run, and we now have our for loop results of 1 to 10. For each loops are very similar. The difference with a for loop versus a for each loop is that the for each loop is designed to iterate over an existing collection, an item at a time. A for loop is designed to iterate over a series of numbers, increasing by an interval based on what that given interval is. So a for loop is much more flexible and it's somewhat independent. Its only dependency is based on its logical condition, which is that second part of the for loop, so this I is less than or equal to 10. For each loop actually needs a collection of data in order for it to function. So the first thing that we'll need to do is we'll need to create a collection of data. In this case, what I'll do is I'm going to create an array of strings, and I'm going to call it my data. I'm going to use a syntax for defining this new array, and I'm going to say new string array, and I'm going to initialize some values in line. So I'll start by putting my first name, comma, my last name, and I'm just going to add a series of names. I now have a series of different names that I can then iterate or loop over. So in doing this, I can now say for each string name in my data, and I can then output to textbox1.text the value of that name plus the environment new line. I'll add a header. This will be our for each loop results. And then we'll loop through that collection of strings and output those to the text box. So F5. And there is our for each loop results. Now you'll notice our for loop results disappeared, and the reason for that is that on line 32 I did an equals instead of a plus equals. So instead of appending to what's already in the text box, we actually erased it and replaced it with the for each loop results string. By adding the plus sign back, I can run again, and I then end up with both the for loop and the for each loop results. For formatting, I'm going to add an environment.newline to the front of this, and that will provide an extra space inside of the text box. Alright. While loops are based strictly on logical statements. So a for loop has both an initializing value of I, or whatever variable we want. We could make this J or Steve or anything like that. But while that value is within these parameters and this resolves to a true statement, this code gets executed, and then at the end of this loop, it'll iterate or progress to the next step. This is a nice, concise package. A while loop, on the other hand, requires a little bit more work and is basically it's logic driven. So we can do it in a lot of different ways. We can say while true. We can have it do some kind of work. We can also do something such as int j equals 0. And we can say while j is less than 100. Do some work, and then the last step is I want to increase j. So we do a j++. So our work could be something as simple as maybe we're just outputting those numbers into the text box. So we'll say textbox1.text plus equals environment.newline plus while loop results. And then we'll say text equals j.toString plus we'll just do j.toString, and then we'll put an if statement in here and say if j mod 10. And if you're familiar with mod, you'll understand what this does. If not, I recommend looking up mod. It's a nice little feature. Basically what happens is that whatever the value of j is, it's divided by 10, but the mod returns a remainder. So if j equally divides into 10, you'll have no remainder. If it does not divide equally into 10, then it'll have a remainder value, therefore we're not going to get every 10. So the objective here is that if j mod 10 equals 0, then we should have 10 items spit out on the page, and then from there we can do a new line. And that just allows us to kind of keep things a little tighter. So if we do an F5, we end up with 99 only showing. Oh, forgot my plus equals, so let's refresh again. And here is our for loop results, our for each loop, and then our while loop. So it starts off at 0. 0 mod 10 is 0. So it puts a new line, and then we go from 1 to 10. 10 is divisible, so new line, 20, 30, 40, all the way down to 99. With some modifications, we can adjust this. So we'll say 1 while j is less than or equal to 100. We can do a new line, and then we will add a comma just for clarity. And if we run again, we'll then end up with much more readable results. So there's 1 to 10, 11 to 20, 21 to 30, all the way to 100. So that is our while loop logic. Alternatively, we could do a true, and then we could have an if statement in here that says if j is less than or equal to 100, do a j++, else break. And break exits a loop. This will exit the loop and it'll stop it from executing. This will keep us where we need to be and continue on to the next line of code after the loop is over. If we do an F5 again, we end up with the same results. We actually end up at 101. Our evaluation will take us saying if j is less than or equal to 100, which 100 is the upper bound we want to hit, it will be true at 100. It'll then go ahead and do a plus plus on us. It will then loop back one more time and output 101, which is what we saw in our form window. To resolve that, we actually want to go back and say while j is less than 100, that will then give us an output up to 100. So essentially this while loop is performing the same work as the for loop, but there's a lot more work that goes into doing it versus a for loop. So the for loop, whenever you're iterating over numbers or you have very simple loops, they work very, very well at doing that work. For each loops, again, if you have an existing collection, they work very well. While loops tend to be a little trickier. Now, you have a while loop and you have a do while. The difference is that before the while loop enters the loop body, it will try to evaluate what's in the parameters. So if this was something like j is less than 100 and j was 101, this loop would never run. The loop would always be skipped. Nothing inside of that body would run. But if you wanted it to evaluate the first time or run the body the first time before it does the evaluation, you can use what's called a do while. So what the do while loop will do for us is it will create a loop. It will execute the loop body one time before it attempts to do the evaluation. In this case, k is already at 100, but this while statement won't know that until it falls through the loop body. So let's actually make this 101 just to kind of illustrate the point. So even though 101 is greater than 100, the loop body is evaluated before the while logic takes hold. So let's go ahead and run this. And I'm missing a plus equals somewhere, but you'll see that it output 101. I'm missing it right here. So once it hit 101, which really it probably evaluates as 102 because we have a k++, it stops running. If we were to, let's say, make this -10, go ahead and run it again, it will then output the do while loop until we hit 100. All these are different types of loops. They all have their own kind of advantages and disadvantages. They all have their purposes. They all exist because they have unique purposes where they meet a specific need. But these are all different ways of looping through data or creating iterations through your data where you're needing to handle events that are continuous or reoccurring. As you get into building your application, you'll find needs for these loops, whether you're looping over a collection of data coming from a database, from a web service, or trying to handle elements within a form and needing to loop through all the elements in a form. So these are all valuable tools in doing development.